This video is going to show you why ionic compounds form the way they do. The first thing I want to remind you is that an ionic compound is formed between a metal and a nonmetal. And let's just do some basic physics here. If we have a metal plus a nonmetal, we know that metals form positively charged ions and nonmetals form negatively charged ions. In physics, when you have a positive and a negative particle near one another, they attract one another. They feel a force of attraction that pulls them towards one another. That's what an ionic bond is. So in this first example I want to show you, I'm going to take the element calcium. Calcium has 2 valence electrons. It's located in group 2 of the periodic table. And you recall that every element in group 2 has 2 valence electrons. And then I'm going to take the element fluorine. Fluorine is in group 17 with the halogens. It has 7 valence electrons. Now remember, what makes these elements more stable is to have a noble gas notation where they have 8 valence electrons. So calcium is going to want to give away one of its valence electrons to fluorine. When that happens, fluorine gains a negative charge with that one extra electron. But calcium still has this other electron, so we're going to need a second fluorine to be able to satisfy that calcium. This fluorine also has 7 valence electrons, so that second valence electron from calcium will be transferred to the fluorine. Now we have a calcium ion that has a charge of positive 2 with that noble gas notation. And we have 2 fluoride ions, each with a negative 1 charge. So when you do the charge and crisscross method with these charges, the way we've learned in class, the ratio that forms between these two is 1 calcium and 2 fluorides. So this is the formula for calcium fluoride. The charges stem from the valence electrons, and then the transfer of electrons happens in an ionic bond so that both of the ions, or all of the ions in the formula, have that noble gas notation.